Swayam Prabha. Digital India. Educated India.
Hello students, today we will look at green building, a very well known concept today in the 21st century. Lot of people in architecture talk about green buildings, low carbon construction, sustainable design. We may not be able to look at the entire gamut of issues that are being talked about, but through a few examples we will look at what green buildings are. But I will begin by telling you how this whole thing became so important for us in the 21st century. It all really, if you want to look at the beginning of the whole problem, it began with the energy crisis the world faced for the first time in 1973. There was a dawning realization about the problem of energy. There was an oil embargo by the oil producing countries, the organization called OPEC, and this sent oil shocks all over the world. There were fuel shortages, skyrocketing oil prices, long queues at petrol pumps, and showed there is a global dependence on fossil fuels and the vulnerability of energy security. Then the impact of carbon emissions on climate. The damage from carbon emissions began to be understood from the 1960s, but there was a strong global recognition in 1970s to 1980s. Early reports started coming out as early as 1979 with the report Carbon Dioxide and Climate, a Scientific Assessment, a Charney report. In the 1980s, private documents were there by oil companies like Shell and Exxon that was secret in the 1980s, warning about climate change. Then important milestones came about. In 1987, the Brundtland report came out, and that talked about the framed sustainable development globally influencing building policy. In 1990, the first green building standard certification called BREEAM came out in the UK. BREEAM stands for Building Research Establishment Environmental Assessment Method. It focuses on energy to materials, pollution and health. 1993, the US Green Building Council was formed, the USGBC, and the LEED rating system was established in 1998. Around this time, concepts like life cycle energy, embodied carbon began appearing in research work. Then important milestones in 1997 was the Kyoto Protocol called COP3, the first binding international agreement to reduce greenhouse gases, and buildings were identified as a major sector for energy reduction or carbon reduction. In the 2000s, there was rapid growth of LEED and BREEAM and Green Star, etc. Building performance became a mainstream concern, and in 2007, the fourth IPCC assessment report declared that buildings offered largest, most cost-effective opportunities for carbon reduction. 2015 Paris Agreement COP21 put net zero carbon buildings on the global agenda. Now, probably last year a UN report by the IPCC came out that declared what was called as Code Red, that global temperature was likely to rise 5 degrees Celsius in the next 20 years. But 5 degrees Celsius from what? 5 degrees Celsius from the time of the Industrial Revolution. Global temperature would rise 5 degrees Celsius above the temperature during the time of the Industrial Revolution. If that happens, there will be irreversible climate change and global warming. Already we are seeing the impact of tremendous climate change. Literally a climate change catastrophe is happening with extreme heat waves, drought, flooding, melting glaciers, rising sea levels, especially in areas where we never expected before. Floods, for example, in Frankfurt, droughts in areas that did not witness them before, forest fires are happening. So as a result of this, globally there has been these caps established on the amount of carbon emissions nations can emit. For India and China, the cap for bringing the country to net zero carbon level is 2070. That is, by 2070, India is striving to become a net zero carbon nation. Currently, the global carbon emissions, China is at the forefront with 27%, USA at 11%, and India is the third largest carbon emitter with 7%. Now, when we talk of carbon emissions or energy consumption in buildings, what are we really talking about? We are talking about two things. One is what is called as the embodied carbon or embodied energy, that is the energy required to make the materials, manufacture the materials used in construction and to transport them to the site of construction, the overall energy that is embedded in the materials. The second is the operational energy or operational carbon, that is that energy that is consumed during the operation of the building. Data reveals to us that buildings contribute to a total of 38% carbon emissions globally. They are the major contributors according to the 2020 Global Status Report for Buildings and Construction by the United Nations Environment Programme. So, that is why it is vital for us to target buildings to lower carbon emissions, to lower the energy that they consume. Now, in order to understand the concept or the difference between what is a sustainable building and what is a green building, the concept of sustainable development or sustainability incorporates three principal things. Number one is the environment, number two is the economic aspect, and number three is the social aspect or the people. All three put together lead to sustainability or sustainable development. But green buildings specifically focus on the environmental aspect of sustainability. That is the difference between being sustainable and being green. There has been a lot of impetus to make green buildings, and now we are also moving towards more and more sustainability. That means the social aspect and the economic aspect is also becoming important. In fact, when we look at the sustainable development goals that were set up in 2015 by the United Nations General Assembly, it was intended to be achieved by 2030. Out of these SDGs, there are 9 SDGs that is a direct impact of green buildings. So what is a green building? I will give you very simple definitions. You can go and read the detailed definitions later. So, a green building is the reduction of the negative environmental impact through the design, the construction and the operation of a building. When we talk of bioclimatic design, there are some top rated green buildings that we have in India. The one we will be looking at is the CII Godrej building in Hyderabad by Karan Grover. Then there is the TZ Homes in Bangalore, Suzlon One Earth campus by Christopher Benninger in 2009, Infinity Benchmark in Kolkata, the Rajiv Gandhi International Airport in Hyderabad, the ITC Green Center in Gurgaon in 2004. So, green building is that which consumes the minimum natural resources during its construction and operation. Green building, there is increasing efficiency with which buildings use resources, energy, water and materials, while reducing the building's impact on human health and environment through better siting, better design, better construction, operation, maintenance of the building, and finally the demolition and removal of the building. The entire building life cycle is a model of a green building. So, when we talk of life cycle energy requirement, again we will look at these two things I have just mentioned, the embodied energy, which is the energy needed to quarry, manufacture and transport materials used in building construction. Operation energy is the energy to operate the building used by occupants for heating, cooling, ventilating, lighting, operating equipment, etc. in the building. How do you reduce operating energy? Today in this presentation we are not looking at the embodied energy, embodied carbon aspect of it, though that is also considered more energy efficient, low carbon materials need to be used as a part of the overall green building concept. But when we talk of operating energy, two things are important. One is energy saving. How do you save energy? There are passive and active means to save energy in a building. By improving insulation, by automated ventilation controls, that is the active part, by lighting control using natural light, by lighting control using motion detection sensors, by high efficiency light fixtures, by rooftop planting, which are called roof gardens today. Through all this we are trying to save energy. The second part is energy making through, for example, photovoltaic generation, use of solar PV panels. So on one side we are saving energy, we are lowering the amount of energy the building consumes. On the other side we are making energy. The energy that the building still consumes is provided by the building itself through things like photovoltaic panels or even through geothermal energy, or many other means are being explored today. So both these aspects can work together to lower the energy consumption of a building or the energy that it takes from the city grid. Why make buildings green? Not only is it important because of the most important or critical issue that we need to lower carbon emissions, but also studies reveal that productivity gains up to 16% happen with green buildings because they reduce absenteeism, they improve the work quality or the work in the overall indoor environmental quality. Therefore, there are environmental, economic and social benefits for all building stakeholders. So here we are actually looking at the very essence of sustainability. Though it is a green building, but it is also impacting economic and social aspects because there is less absenteeism, the indoor environment is better, people find better to work. Economically that benefits the companies or the corporations. So owners, occupants, general public, everybody benefits with these green buildings. Green building should create delight when entered, serenity and health when occupied, and a regret when departed. This is a statement from the book called Natural Capitalism. The building that you are seeing in this picture, in this slide, is the Bosco Vertical, the vertical forest in Italy by Stefano Biori Architetti in 2014. There is another building, the One Central Park in Australia by Jean Nouvel, another green building in 2014. Today there are a variety of green projects coming up globally: residential, exhibition centers, hospitals, airports, laboratories, IT parks, corporate offices, government buildings, so many building typologies in which green buildings are being made. Why are people attracted to green buildings? Top 3 reasons is, of course, there are operational savings, 40 to 50% less energy is consumed. There are water savings, 20 to 30% less water vis-a-vis conventional building. An incremental cost that happens because of making green building, a 5 to 8% over and above the conventional building, of making a conventional building, is paid back in 3 to 5 years time, what is known as payback period. So there are better daylight and views. Like I said, working environment improves, access to daylight and views is there, productivity of the people goes up, air quality improves, it is fresh and healthy. Interior materials are also used in a way that they have low carbon emissions. Now the problem was the buildings have major environmental impacts over the entire life cycle. Resources, they cause depletion of ground cover, forest and water. Materials, we use resource intensive materials in construction. In landscaping, though they add beauty to the building, but we use water and pesticides for the maintenance of the landscape. We use energy consuming systems within the building. We use high-tech controls, building management systems that add intelligence to the buildings but require a lot of energy. Water that is continuously consumed during the building construction as well as operation, and waste generation. Several building processes and occupant functions generate large amounts of waste. Thus, buildings are one of the major pollutants that affect urban air quality and contribute to climate change. That is why the objective of the green building is to maximize the use of energy efficient materials and construction practices. So, if you look at it, minimize the demand for non-renewable resources, maximize the utilization efficiency of the resources we use, maximize the utilization of renewable resources, and maximize reuse and recycling. All these concepts are evolving even further today. The objective is energy, minimum energy to power the building, energy efficient material for lighting, air conditioning, etc. Water efficiency, use efficient waste and water management practices, working conditions, provide comfortable, hygienic indoor working conditions. So we come to the CIA Godrej Green Building Center in Hyderabad. Why is this an important study? Not only for Indian architecture but global architecture, because this is the first structure outside of the USA to receive a platinum LEED rating. In this presentation, I am not giving you the entire description of the LEED and GRIHA green building certification. You can read it up, but the LEED rating as given earlier by the US GBC, now we have also the Indian part of the Green Building Council called the IGBC, Indian Green Building Council. The CIA Godrej building in construction combines both ancient practices with modern architecture, reaffirming the applicability of traditional architectural knowledge in today's notions of sustainability. The building is green not just in its making but also in its purpose to promote sustainable practices in India. The center is for research and development efforts related to energy, environment and climate change, and the idea was born during a visit by the then President of America Bill Clinton in 2000. Karan Grover Associates in Baroda are the architects behind it, developed a design scheme to respond to both the cultural and the environmental context. The building was to be a showcase for energy efficient, eco-friendly architecture, an integration of age-old practices with sustainable practices using modern technologies. The building is 20,000 square feet of space with circulation scheme that encourages interaction. It's got introverted courtyard, they're inside yet outside, leading to traditional gathering spaces. They're ideal for bringing in natural light into the building and for climate control in this hot region. All enclosed spaces are coupled with smaller open courts which are encircling the larger court or the larger courtyard. The large central courtyard, which is a key to the sustainability success. Energy efficiency, the most important feature, it boasts of light energy savings of 88% with respect to a conventional building of the same size, both energy efficient lighting systems and extensive reliance on daylight. This is how cool north light is brought into the building and it washes the interior spaces. The courtyards act as light wells, eliminating the adjacent work areas. When light is insufficient, sensors trigger energy efficient electric lights. There are also dimmers that automatically control illumination levels and turning lights off when it is unnecessary. There are occupancy sensors that prevent light from being switched on at unoccupied workstations. Please also remember that this building was made much earlier in 2003. Over this time, much more development has taken place in green building or energy efficient design. Far more new strategies are now being implemented, but we are looking at it as an important landmark in green building design in India. The building layout ensures that 90% of spaces have natural light access and views to the outside. In some areas, jalis are used to prevent glare and heat gain while ensuring adequate daylighting and views. The jali is also giving aesthetic appeal to the space. Contemporary strategy for energy efficiency is the use of solar photovoltaic cells. There is a rooftop grid that provides about 24 kilowatt, approximately 16% of the building's electricity needs are met through the solar PV panels. And for energy efficiency, another traditional method from the Middle East has been used that brings in, that is these two wind towers that you see here. These wind towers are traditional elements that catch air at a height, cool it as it passes down the tower. That cooled air is then pumped into the HVAC system or to the air handling unit of the air conditioning system, and this air has been cooled by up to 8 degrees Celsius, bringing about a substantial reduction in the air conditioning load. The roof itself is heavily insulated and reduces the overall cooling load. Just to repeat this again, the the air from the top, the hot air is pulled into the tower. As it comes down, it is pre-cooled within the tower, and this cooled air is fed into the HU. So now what happens? For example, if the outside temperature is 45 degrees, the air conditioner has to work to bring that temperature down to, let's say, 26 degrees Celsius within the building. That is approximately about let us say 19 degrees. 19 degrees of temperature drop has to happen. But because of this system, that 19 degrees becomes just about 11 degrees Celsius, and that tremendously lowers the cooling load of the building. There is also sensitivity to the context. Part of the green task is to minimize damage to the natural elements during the construction and occupancy. Water flow, air quality, vegetation, topography, all aspects are looked at. The building form responds to a rocky site. The footprint of the building is kept small. Arrangement of spaces, varying levels of plinth are designed to respect the distinctive boulders. That is, the topography of the site is kept as intact as possible. During the construction, barricades were installed to prevent the contaminants from the site from spreading to the surrounding areas. The vegetation that was lost to the built area was replaced by these rooftop green spaces or roof gardens up to 55%. The architect ensured that some rainwater would go into the soil by specifying the permeable grid pavers. Now, the remaining rainwater follows the existing flow pattern of the site and is collected in a water pond. Another traditional method is that it is constructed at the lower end of the site. All wastewater generated by the building is recycled by what is called as a root zone treatment. That is a purification technique that uses specially selected plants and weeds as filters. This method simultaneously irrigates the vegetation also. Treated water is also directed to the pond and used for domestic purposes. In addition, the building achieves 35% reduction of municipally supplied potable water, in part by using low flush toilets and waterless urinals. Another aspect is, for example, the broken tiles during construction are reused again to apply them on the columns as tracandis. I have already talked about it in the works of Gaudi, etc. The tracandis, the use of broken tiles. Again, the sensitivity to context is the building occupants are encouraged to minimize their, so now shifting from the building, even how the occupant behavior is controlled, or they are encouraged to minimize their reliance on fossil fuel based transportation. The building is located near a public transport station, so people can use public transport to come to work. Bicycle riders are treated preferentially. They are provided facilities like convenient parking, lockers and showers. 30% users have shifted to alternative modes of transportation like carpools, bicycles and cars that run on LPG. Then I am talking about 2003. They were also encouraged, or rather the center bought locally available, locally made electricity driven cars called Riva in the hope that employees will buy alternate energy power cars in the future. Now this is old story, because today EV cars are becoming very, very important even in our country. All over the world we are moving towards a situation where most of our vehicles will be EV vehicles. Documented reduction of harmful emissions through design, siting and construction indicate there is at least 62% carbon monoxide, 63% of hydrocarbon nitrogen oxides. That kind of reduction has happened through this building. This demonstrates that traditional knowledge is valid today and it can be used in conjunction with modern architecture to achieve these levels of sustainable design. It's earned a very high LEED rating of 56 credits, a platinum rating, which urges us not to turn our backs to history in our quest for modernity. So this building in 2003 formed a benchmark of green building design, but like I said, lot of other developments have happened over time. Let's again look at a benchmark building of 2006, the Hearst Tower in New York by Norman Foster, a green high-tech building. Earlier building that was there was the building by William Randolph Hearst, which is an Art Deco structure originally designed by Joseph Urban, and Foster designed his iconic tower above it while keeping intact the 6-story base. So this is the before renovation picture, this is the after renovation picture. 46-story building, 80,000 square meters of office space rise above the old building. Pioneer in environmental sustainability, the first commercial office building to receive the gold LEED certified rating for core and shell interiors in the New York City. In deciding upon the rating, the council considers all these aspects like site selection, water energy use, indoor environmental quality, the type of construction products used, etc. And over 90% of the structural steel used in this building has come from recycled material. About 85% of the original structure can be recycled for future use. It has got an innovative die-grade system. We have already seen this in the Gherkin or the Swiss Re building, also by Norman Foster in London. There is no horizontal steel beams used. Each triangle in the die-grid is 4 stories or 54 feet tall. Die-grid frame was not thought as a way to enhance the tower's green building status, but what happened was the structural superiority of the die-grid reduced the overall steel required for the structure by 20%. That is, this building uses 8,500 tons as compared to roughly 10,700 tons for a comparable building of this size, saving 2,000 tons of steel, a major contribution towards this green building status. This is how the form of the building evolved, the die-grid frame, and the die-grid frame also has superior structural efficiency. For example, it keeps the interior work areas uncluttered from pillars and walls. Now, the entire facade of the lower base has been preserved. It was gutted and filled with this 7-story atrium. The lobby with atrium occupies the entire floor plate and then rises the 6 stories from the lobby, rises 6 stories of the old building, has main elevator lobby, cafeteria, auditorium, etc. And there is transparent skirt of glazing that you see here, as you see here, which brings in natural light into this space. The structural elements of the main lobby start at the 3rd floor and rise up to the 10th floor. This is the 12 meter of glazing that has been provided, the skylight, and it provides natural light into the building. Along with that, there is glazing also rising like a clerestory window on the perimeter of the new tower, and this also brings in natural light. So, from the skylight and the clerestory window, natural light floods into the 7-story atrium space. This is how the atrium is, the clerestory, the skylight, the die-grid, how the structure has been formed. So the lobby is the celebratory communal space, it is a town square, and there is also a 3-story waterfall provided in the atrium called the ice fall, and the sense of calm in this monumental scale, it is the nation's largest sustainable water feature. 3-story high stepped slanted waterfall with these angled escalators. There is a half-inch surface of water and some 15,000 gallons per hour of water. It is built on 50 tons of glass. The waterfall helps to control the climate in the building by providing humidity and by cooling the large atrium in summer, thus reducing the energy cost of the building. The environmental strategies used in this building, there is rainwater harvesting, low emissivity, glass facade, daylight sensors, activity sensors, high efficiency heating and air conditioning. They utilize outside air for cooling and ventilation up to 75% of the year. Minimum internal walls that maximize daylight penetration in the building. 85% of the original structure can be recycled. Energy efficiency of 22% with respect to a standard office building. Walls are coated with low vapor paints. Workstations and offices are furnished with furnitures which are formaldehyde free. Concrete surfaces are furnished with low toxicity sealants. Floors and ceiling tiles are manufactured with recycled material. Therefore, it got the International High Rise Award in 2008. Sustainable Office, the first green building in New York to receive the gold LEED rating of core and shell, an interior iconic building, yet a very environmentally responsive tower. With regard to energy efficiency, Norman Foster has been at the forefront in making buildings that bring about energy efficiency. Then we have the CH2 in Australia. By designing, we'll quickly rush through it. This is the first building in Australia. They got the 6-star rating on the Green Building Council of Australia. There are wind power turbines that cool the building in night. Chilled ceilings are used. The building power system includes photovoltaic cells, solar hot water panels, a gas powered cogeneration plant. A cogeneration plant is one that the fuel that is used to produce the electricity, that same fuel, the heat from it is reused again for other purposes within the building. The ducts are on the north and south of the building that utilize natural heating and cooling to in ventilating the building. There are light shelves that have been provided here that bounce light into the building, increasing the overall natural light in the interior of the building. The north facade, because Australia is in the southern hemisphere, it is the north facade that gets the maximum light. In our case, that would be the south facade in the northern hemisphere. Therefore, it is covered with the vegetated facade to filter the sunlight, and also the glare is controlled with louvers and other shading devices. Recycled timber louvers are used and are controlled by photovoltaic cells. There are these 5 shower towers that have been provided to lower temperature to around 21 degrees centigrade and to lower the water temperature to 12 degrees centigrade. Evaporative cooling effect to cool both air and water for the building cooling. Recycled timber louvers have been used, and these are the shower towers. On the shaded side, use evaporative cooling to cool both air and water for the building cooling. Please read the detail about this building, you will understand about the shower towers. Some examples of contemporary green buildings that we have, and we can see how fast we have moved in the way green buildings are being designed today, like the Bullitt Center in Seattle, and this is called the greenest commercial building in the world. Net zero energy, net zero water, composting toilets, the Bosco vertical, the vertical forest that we just saw, twin residential towers with 900 plus trees, 20,000 plants integrated into the facade, improves air quality, reduces the heat island effect, and creates urban biodiversity. The Edge in Amsterdam, which is considered to be the smartest green office building in the world, which is for the Deloitte company, solar powered aqua thermal energy storage and integrated smart systems. If you recall a few lectures back, I talked a little more in length about this building. Then there is the Park Royal Collection in Pickering, Singapore, and this is a hotel which is as a garden with lush green sky terraces covering 200% of site area in greenery. Rainwater harvesting and natural ventilation strategies have been used. Thus we find that green buildings have come a long way today, and far more strategies are being employed. Lot of research is being done to make our buildings more and more sustainable, more and more low carbon, more and more green. Thank you.